speaker for the evening, Eric Upton, Pierce Software. Thanks to Mike and the AOL team for having us. Mike's going to present in a second. And Bill, Ted, the Arista folks are going to be kicking us off. Title of the deck is?
Yeah, so it's mostly just around network provisioning, and then it's including some best practices using Ansible. So
best practices. So thanks for coming out. We do these monthly. You know, they kind of float around. Fierce Software is a Ansible bar, so we like to just come out, buy some beers, hear how the community is using it. We're an open source bar, so we like to have these sorts of hands-on meetings.
Are the future meetups are going to be in this location, or because I remember one was in Capital One?
Well, we avoided Tyson's because of December, and you know.
Yeah.
But yeah, they'll float. Fierce is probably going to host the next one. That'll be rested.
Okay.
I mean, feel free to raise your hands at your respective companies. I mean, that's what Mike and AOL did. Basically, just said, "Hey, it'd be cool to have you guys in for one." And he said, "It'd be cool to have you have us." So, yeah, basically Northern Virginia.
Okay.
There is a DC users group as well,
Right.
and we kind of do similar stuff, but a little different. So that's it. That's my commercial. Ted, Phil, take it away. Thanks.
Okay, I'm just going to very quick introduce myself and the others from Arista. My name is Ted Gagnon. I'm the territory salesperson here in the state of Virginia. And Mo Schrain is one of our systems engineers in the area as well. So, you know, the show is really all about Ansible. What we're going to do is, at the end of Phil's presentation, we're going to pass around a fishbowl, ask you to put your card in, and we have 2 Arista Warrior books. Just going to raffle them off. Arista is an interesting company, but we're all about open source, all about connecting the best of breed together inside the data center. And if you don't know about Arista, it's a great opportunity to learn more about us. And if any questions come out of this session, you want to follow up, you can always reach out to me as well. We're local. Okay, so thanks again for having us, and hope you enjoy.
yeah, that's a great sort of segue into this presentation.
Yeah, sure. Your preset.
I have it plugged in. Okay. So my name is Phil DeLeo from Arista Networks. I work in the EOS Plus Consulting Services Group. And what that is a small group of professional service engineers as well as developers that sort of, our main task is to leverage the native and inherent extensibility in the Arista EOS operating system to integrate with other third parties. We work quite a bit with open source tools. And so one of them that we spend actually a lot of time on is Ansible. And so tonight, the overall presentation is really to talk about what we've done at Arista to integrate Ansible with our products. I'll go over just a sort of a quick introduction to Ansible, since this is an Ansible meetup group, for those who are maybe new to Ansible, just so that we're all sort of on the same playing field. And then we'll go into some best practices, and then I'll show you a demo using some Arista virtual devices and simulating what it would be like to take an Arista switch out of the box, rack it up, wire it in a spine leaf topology, and then zero touch using Ansible Tower with just one click kicking off a tower job to bring up MLAG, BGP, virtual router, sort of the whole gamut of features on your Arista device. So the first thing I like to talk about is football. And that's because when we're talking about Ansible, we're talking about playbooks. So when you're talking about playbooks, you're talking about sports. So hopefully there are at least a handful of football fans in the audience. And so if you're going to look at this play, and if you focus primarily on the play on the left there in red, there's a wide receiver running a certain route. Does anyone know, like, if you were the coach and you were talking to your wide receiver and you said, "This is the play I want you to run," what would you tell him?
Run a post.
Run a post? He says, "I have no idea what a post is. Can you make it a little simpler for me? What is a post?"
You're going to run about 10 yards down the field and run towards the goalpost.
Okay, perfect. So you'd break it down you'd break it down for him, and you'd say, for player A, I want you to sprint 10 yards. I want you to slant at a particular angle. I want you to run an extra couple yards and then catch the ball. Now, that play is generic enough for any wide receiver to run, but all my wide receivers don't have the same skill level. So I have to slightly change it depending on which wide receiver is running the play. So here you'll see we have Odell Beckham. I'm from New York, so why not? And then some third string player who's maybe not as fast. He's coming off the bench. He's not as good. So his play is tweaked just a little bit for his skill level. So he's going to run a little slower. He's still going to slant at 45 degrees. So that's common amongst both players. But he'll run a little bit slower, a little bit, some fewer yards, and he'll catch the ball at a slower speed. So if we start to think about data models, right, like how do we look at this and then break it into a data model? So the notation I'm using here is YAML notation for a dictionary. So we have this object called slant route, and the attributes of the slant route object are going to be sprint 10 for Odell Beckham, post slant sprint 5, ball speed 60. So that perfectly models the play he's going to run. They're the same corresponding attributes for the other player, except his values are slightly different. Then you'll notice at the bottom, we have a group variable, slant angle. And since that's common amongst both players, we'll pull it up a level to a group variable. So all people in the wide receivers group will slant at 45 degrees. So if we take this concept of this wide receiver running this post route, we can sort of map it to an Ansible playbook. And it would sort of look like this. We would have a players file, which would define a group called wide receivers. And that's noted by that square bracket with wide receivers. Within that group, we have two players, Odell Beckham and third string. So on the right side, we have, again, this is YAML notation. We'll say which players are going to run this play. Wide receivers. So here I'm specifying a group who are that this play, who's incorporated in this play. So wide receivers. So that's the first step when we're executing through a playbook. Who's going to run this play? Then we have to find out which players are part of that group. So we look in the hosts file and we say, okay, wide receivers group, we have two players, Odell Beckham and third string. Great. Is there any information that's common to all players in that group? We look at a standardized directory structure, and we'll look in the group vars folder, and then we'll look for a file with the same name as the group name. So we find the wide receivers file, and we grab the attribute slant angle 45. So if you can sort of imagine Ansible starting to gather this information, it now knows who is going to run this play, and it's starting to go into group variables and host variables to sort of build this cloud, this object, this dictionary of attributes for the play. So the first one we have is slant angle 45. Then number 4, we're going to grab player-specific variables and attributes. So we'll look in player vars for Odell Beckham, and we'll grab that dictionary that's assigned to him. Now, at this point, the playbook is going to fork, and we're going to run this set of plays for Odell Beckham in parallel with the third string player. So, and this is a common Ansible, there's a fork limit, usually set to 10, but it's going to parallelize this set of tasks and run through them in parallel. So finally, we're going to run the tasks. So we have all this, we have all the data for both players. We have the group variables as well as the user-specific or player-specific variables. And then we start running through the tasks on the right. So you'll see in blue, we have a name of the task. And that's just a way for us to have some human or easily readable text while we're debugging. We know exactly what the task is doing. In red, we have a module name. So the first module here is sprint, or sprinting. Then in green, we're going to pass in some key value pairs, which help the sprinting module know what to do. So here you see the double curly braces. That's going to be a Jinja variable substitution. So distance equals slant underscore route dot sprint. So Ansible has in its facts for this play, it has that object, slant route. And so it goes to the sprint key, and then it substitutes 10. So the distance equals 10. And then it goes down the line, doing all the variable substitution, running those tasks with the corresponding values for the player. So if we take a step back now, Ansible, really all it's doing is taking data, and this data can come from host var files, group var files, it can come from a database, it can come from a Git repo, or it can come from just static CLI config lines in the case of networking device. Then we take all that data, and then we have some method of executing that data. So it's sort of like if you're developing a Python script, you have generic methods, but then they're really only run with a certain set of parameters. So that data is the input into the execution. So Ansible is really focused on the execution of taking that unique data per host and then executing some series of tasks, and then ultimately in the networking perspective, it's going to end up as running config on the switch. So hopefully that's a decent introduction to Ansible. Any questions about some of that?
Does Arista equipment support? So Ansible collects information about the node, right? Kind of like facts from Puppet. So in the typical host, I can collect information about the environment, operating system. Is there something like that in the Arista equipment that Ansible can read and you can use system variables to do certain actions?
Yeah, so what you can do, we have a module called EOS Facts, and you can run that as a pre-task or one of your first tasks, and it can do a show version, it can do a show interfaces, it can do a show anything you want, pull that information back into the playbook, and then register that as a variable in your playbook, and then you could say, for instance, EOS version is 4.12.15, 4.12.5. And then you have a task that says, it's called upgrade switch. And it runs only when EOS.version is less than 4.14. So that's how you would get information from the switch dynamically, and then only run certain tasks based upon the information that came back. So just some real key points for using Ansible is that it is simple. At Ansible Fest recently, there was a comment from a customer that said, you know, Chef is like having a collegiate degree, you need a master's or a bachelor's. Puppet is like having a high school degree, and Ansible is like graduating elementary school. So it really is meant to be simple. It's meant to have a very low barrier to entry, and so that's why we see a lot of interest in it, especially when it comes to our equipment. Along those lines, the playbooks are written in YAML, so you don't need to know how to develop Python code to use Ansible at all. It's a benefit if you want to customize or write your own modules, but you can do plenty of damage by just knowing how to format your playbooks in YAML. Yeah, Jinja YAML, both very simple, right? It's agentless, so you don't need anything running on your switch. So in the example of Puppet, you have an agent running on the switch that's going to collect information locally and then talk to the master and then figure out what it needs to do. Ansible is going to be centrally driven from, and that's how we've implemented it for Arista, is everything is going to happen centrally on the control host. It'll reach out to the switch, gather some information, and then run commands from the centralized server. In the topologies we support, you can connect to your Arista device via SSH or SSL. It's meant to be used within your entire organization. You can have pretty much anyone, whether it's a zero-touch activity or day one provisioning, or just doing something simple as adding some users, adding some VLANs. You can change your playbooks to include different things so that different people can use it. And then finally, one good feature is Tower. So it allows you to operationalize Ansible. It gives you a lot of flexibility and structure around auditing who ran what, scheduling it, and integrating with SCM. So you may ultimately get to the point and say, why do I need Ansible? Or why should I use Ansible? Why not Puppet? Or why don't I just write my own Python scripts? I'm a good Python developer. I can write some bash scripts. And then I know exactly what it's doing. I have full control. So does anyone know or have any opinion why they would use Ansible versus some homegrown Python scripts?
You don't have to deal with somebody else's Python code.
It's true. You don't have to inherit the guy's code who wrote it 20 years ago or left the company. Any other sort of key features that Ansible gives you?
I think the accounting is easier with this because you control the playbook.
Right.
You know the variables that you are given. So you kind of have an idea of what happened even without going there. Unless somebody messes this, you are pretty much good at accounting on your books. It's like
Yeah, it's
balance sheet
easier.
that you have.
It's easier to go back and just read a playbook real quick and understand what it's doing versus reading Python code and trying to figure out what each of those methods does.
Oh, you can, another thing is that you can hook up your Ansible with some, like you said, the equivalent of an external node classifier in Puppet, where you have a database with all your nodes, and you can pass properties for your nodes, and you can have Ansible read that, and you can have it, you can know how, like the state, how to connect and what ports and all that stuff.
Exactly. And so ultimately we get to a few reasons why Ansible is really a good option. First, item potency. So when it comes to a networking device, you're only going to run config commands that are necessary. You're not, if I want VLAN 1 through 1000 on my switch, I run my Ansible playbook, and before I do anything, I go check which VLANs are currently on the switch, and if VLANs 1 through 1000 are already on the switch, don't do anything. Leave it be. It's perfectly fine. So item potency is the concept that I take a set of data, and I have a set of execution tasks, and if I take that data with that pair of execution tasks, I will always get the same output. So that's item potency. It's manageable. Different people in the organization can use it. It's easy to read. You can use one platform for your entire infrastructure. So you get your networking devices, compute, storage, anything you have, you can use from one centralized tool. And it's community driven. So if I write a Python script, it's just me developing it. If you use Ansible, you have a community of well over 1,000 who are contributing, that have expertise, and that gets you to a more elevated or sophisticated point much faster. So in Ansible, you have these modules, which are essentially the execution, how it's going to do the work. And there are over 400 modules, but there's a lot of modules for common Linux system administration, but not a lot for networking devices. So you want to use Ansible, and you want to use it with your networking devices, but there's not the core support historically. So typically you have two different approaches. If you wanted to go use Ansible today with your Arista devices, you have two options. The first one is one that's been developed longer. We've developed our modules about a year now and put them into the community, and it's an API-based approach. And we'll talk about this a little bit more, but what we've done is we've built a data model around a lot of the CLI configuration, and so you don't have to know the CLI, you just can run simple API methods that will convert to the correct CLI commands and put the right running config on your switch. So that's the arista.eos role. The second method is the newer method, and that was just announced at Ansible Fest last month in San Francisco. And there are now core modules that will ship with Ansible 2.0 and later. And so this is, we'll talk about this a little bit more, but this is a huge advantage for someone getting started for a few reasons. One, you don't need any third-party role or library to install on top of Ansible. Also, this approach is much more easy to use if you're used to CLI. If you're much more comfortable with the running configuration, and the CLI syntax, this method is a lot easier to use. So we'll talk about both of these. So we do have, and we already ship the arista.eos role, and included in that role are all of these modules. So you'll see you can do quite a bit of configuration management on your Arista device today using these modules. And so here's what it looks like. One of the modules we have is EOS VLAN, and you'll see just a sample playbook here. And we're going to say VLAN ID 1, enable yes, name foo. So very, very common VLAN attributes. So what happens is we have our Ansible module running on the control host, the EOS VLAN module. And the first thing it does is the module will run a VLAN.get. Now this VLAN.get is an API call using another library called PyEAPI. PyEAPI is another Python library that we've built at Arista. And what it's doing is abstracting CLI configuration to simple API methods. So VLANs.get, and then the 1 is basically saying, get me all the information about VLAN 1. So instead of doing show VLAN 1 on the switch, if you had no idea what CLI commands to run, this is great because you'd be able to understand simple API methods. And then it's going to go talk to the switch, essentially run a show VLAN 1, format that in a nice dictionary for you, and then pass it back.
Is this the EOS API? Is it like a REST API?
EOS API?
Yeah, it's like a...
Yeah, it's an API running on the switch. It's not a REST API in maybe more the modern form of the word, where everything is object-oriented. This is an API that allows you to make CLI or config or enable command calls, and then get back that response. So you can define whether you want that response back as JSON or text,
Okay.
but not every CLI command is supported on both JSON and text. So here, in this case, if we wanted to configure this VLAN ID 1, we want it enabled, what would happen is we do the get, and then say VLAN 1 doesn't exist on the switch, none would be returned. And then the Ansible module will say, okay, VLAN 1 doesn't exist on the switch, let's create it. So it'll run VLANs.create1, which gets interpreted by PyEAPI to run a configuration command and then VLAN 1. And then it's going to set the name of VLAN 1 as foo. So that's what PyEAPI is doing all the CLI conversion for you. On top of all these modules, we've created about 9 roles, additional roles, that help you, they help you get up and running even faster. So typically, if you have a module in Ansible, you have to go write all the tasks, the series of tasks needed to do what you want to do. But what we've done is we've created these roles that sort of include all of the functionality to, configure VXLAN or virtual router or your system or route control, which is ACLs and static routes, or MLAG or V4 interfaces or VLANs or switchboards. And so and what this looks like is, I'll lost the slide here. And so what this looks like is we present a data model which allows you to just plug in just a handful of values. You don't have to write any tasks. You just include the role and then run it, and it will do all the config for you. All these roles are available through Galaxy. And so with this, as we mentioned before, PyEAPI is a requirement. And so that would, whether you're connecting over SSH or EAPI, you would have to have PyEAPI running either on the control host or the switch itself. So we talked about some new direction from Ansible themselves, where they're now including some networking modules in the core of Ansible itself. And so what that would look like is depicted here, where we would have, and just for example here, we're gonna configure 2 interfaces, Ethernet 1 and Ethernet 2, and like we mentioned before, we'll go get some information about the switch in this task on the right, EOS facts, and that will get us the running config, and then we pass that config the running config into this next module, EOS config, and in this block, we'll pass in all of the running config lines that we would expect to see in that interface. And Ansible is going to do the substitution of our interfaces list into this task, and it's going to make sure that the interface appears as we expect it. So the difference here is that this is exact running config syntax, whereas the previous method was using more of a data model. So what's nice about this is it's very easy to use. If you're comfortable with the switch config and the running config, then you can come in here and in 2 minutes configure interfaces or VLANs or BGP or anything. Any questions about the difference?
So instead of listing all of the configuration lines that you want to put in inside the task, can you put them in a separate template and just pull that in?
So currently, this EOS config module, which is going to ship in the Ansible core, is not actually in develop branch yet. It's still, it'll be merged into develop after 2.0 is released. And so we're going to add more functionality to this. One of the pieces of functionality we're going to add is allow you to pass a URL of a template or a file. And so you could have a Jinja task, a template task run before this that does the variable substitution and then just gives you the final config, and then pass that into EOS config, and it will go and iterate through all those lines and make sure all the config's there.
So this looks like a lot more generic approach, right? So you don't have to have, 30 different EOS modules like you have there.
Yeah. So if you look at sort of the different directions you can go, this requires us to create a module for almost every bit of the switch config, which is nice because it gives you a data model. What's bad about it is it's resource intensive, right? We have to write all of these modules, whereas with EOS config, you can do this yourself, or we can package this up in a role for you, and it takes far less resources to get this going. So, along those lines, the advantage of this new approach is that you don't need any third-party libraries, you don't need our role, you don't need PyE API. You can work directly with the running configuration. It's easy to understand. You can use offline mode with that module, where it will look at an existing state of your switch and then build the commands that it needs, and then it will just store those commands, so you can then take that and then copy it to the switch or execute it any other way offline. And it uses the built-in eAPI connection. Okay, so those are sort of your two methods of working with Ansible and Arista. Now, when it comes to best practices, typically when you start out using Ansible, you'll write a playbook almost per application or per switch or per type of anything you're doing, and you end up with 50 Ansible playbooks. And it's really unmanageable at that point. And if you look at this example, you end up with a lot of duplicated data in your tasks. And the problem with that is if you make a mistake or you want to tweak the BGP config, you now have to go to each and every one of your playbooks and update it. So it's a lot of manual change and a lot of managing of those playbooks. So the solution is to use roles. And I always find this quotation from the Ansible docs entertaining, because they say, we'll pretty much assume you're using roles at this point. You should be using roles for sure. Roles are great. You're using roles, aren't you? Hint, hint. So if you're going down the path of creating one-off playbooks per application or little niche deployments, you really want to start looking at using Ansible roles to make it much more generic. And so what would this look like? In the case of virtual router, say I want to put VARP on a pair of leaf switches. We have this EOS virtual router role. I would create this data model, which has a virtual MAC address for VOS 3 and 4. I have a virtual MAC address, and then my VARP interfaces I have defined. And then all I do is, in my playbook, I say, run this on leafs, and then all I do is include arista.eos virtual router. And in the virtual router role are bundled up all the tasks and modules in order to execute this. And I just run this, and it would set up VARP on my two switches. So what's nice about this is it takes away all the work of having to write the tasks yourself. So that's where you want to get to, whether you develop the roles internally yourself, but you want to be able to reuse these roles as much as possible. And so when you apply this now to maybe more of a site configuration, you have a simple site.yaml, and you include maybe the different tiers of your network. And then in each of those tiers, you just pick which roles apply to that type of device, and you just include those roles or exclude based upon what you need. Okay, so finally, we'll just do a quick demo to sort of show you what we have and what's working and some possibilities for using Arista and Ansible. What we'll show you here is we have a zero-touch provisioning server, which is sort of outside the scope of this discussion, but another open source tool we have that does bare metal provisioning of switches. Then we'll have Ansible Tower running as a separate VM. And then I have my 4 VEOS devices wired up in sort of a bow tie here. And what we'll do is, with the zero-touch provisioning process, all we'll do is enable eAPI. We'll assign a host name. We'll put a management IP on it, and just a simple admin user. So it's bare bones configuration. As part of that provisioning, each of these switches will reach out to Ansible Tower via the REST API and register itself. So in the configuration of the ZTP server, we know which group each of these hosts should be in. And so the host will assign itself or add itself to that corresponding group. So here's the Ansible Tower instance I have running. We already created that leaf and spine group. And as you can see, there's no hosts in either. There are no hosts in either of those groups. Just revert these virtual machines back to ZTP mode, which an Arista device, when it comes out of the box, always starts in ZTP mode, which means it'll DHCP out on every interface looking for a DHCP response.
Kind of basic?
Yeah, sort of along those lines. And so it's looking for option 67, it's looking for a boot file, or it's looking for some script in order to init itself, right? And so what that's going to do is it's going to get a Python script that lives on the ZTP server. And that script will get downloaded to each switch individually. And then in that script, it's going to gather information about itself. It's going to gather version, MAC address, serial number, LLDP neighbors, and it's going to pass that to the ZTP server. ZTP server will say, okay, I know who you are based upon your LLDP neighbors. Take this basic config, take your host name, and then it'll reboot the switch. So we'll see that these are starting up. And so you'll see VEOS 1 through 4 here. And you'll see the message here, no startup config was found, so they start in that zero touch mode. And after 30 seconds, they'll send out DHCP requests on all the interfaces. Okay, so you see this one already got the DHCP response. It's going to execute that Python script. So it's talking to the ZTP server to find out who it is. And it's going down for reboot. So it got a basic configuration, the host name, management IP address, enabled eAPI so that Ansible can talk to it. And it ran some commands from the switch to talk to the Tower API and register itself into Tower. So if we refresh, now we have our 2 spines in Tower, right? So we haven't done anything, we haven't touched anything, and we have updated inventory in Tower. Now, you'll notice that the 2 leaf switches are still cycling. they haven't successfully went through ZTP. And that's because we identify the leaf switches based upon their association to the spines. And so since the spines are still hostname localhost, they have no identity yet, we have to wait until the spines come up with their real hostname, and then the LLDP association for the leaf will be accurate.
Have you considered using a dynamic inventory script to talk to your ZTP server instead of having the host register themselves?
Yeah, you could do that.
Yeah.
Mhm.
It's not this if you don't want to pay for tower.
What's that?
If you don't want to pay for tower.
Oh, you can use dynamic inventory scripts in Tower as well.
Yeah.
Right, to your point though, if you didn't have Tower, you'd have to use a different method because the API wouldn't exist.
So did the Leafs download a different Bootstrap file?
No, so they're downloading, so the Bootstrap file is generic. All it's doing is telling the switch to gather information about itself and pass it to the ZTP server. And then the ZTP server analyzes that and determines whether you should get a config or not. And so right now, it's getting refused because these switches are identified by their upstream spine. And so the upstream spine hasn't come up yet. So the ZTP process will keep failing until these come up, until spine 1 comes up.
Is the ZTP server aware that those are Leafs? Like that's.
It doesn't know leaf or spine, it just knows LLDP associations. So now that spine 1 came up with a real host name, that host name is necessary for ZTP to identify this leaf switch. So you'll see in the next attempt, it'll succeed. And so now it's going down pretty quick. And the same for VEOS4. And then if we refresh our inventory again, we should see all 4 switches. And then if we look in the leaf group, we have our 2 tours. If we look in our spine group, we have our 2 spines. Now, in the rest of the setup for Tower, we have this data center in New York, which is tied to a GitHub repo. And if we go look at that, that's okay. It's tied to a GitHub repo that I think I actually also have up here. Where there is already a host vars file for each of the switches, and you'll see that we've created those data models again with VLANs, interfaces, IP interfaces, route maps, ACLs, static routes, and BGP for the spines. And then if you look at the host var file for the tours, we include VARP interfaces, BGP, and MLAG. So a little more information for the tours. And then if we look at our hosts file, the tours are in the leaf group, the spines are in the spine group. Site.yaml includes both spine.yaml and leaf.yaml. And so this gets mapped into Tower by syncing with that Git repo. Then we go over to job templates, and when I want to configure my entire data center, I have a task that does that. And it's calling the site.yaml that we just saw, so it's going to include the spine.yaml, leaf.yaml. And then once those tours come up, we can run this playbook. Any questions while that's getting ready?
Is the tower acting as the DHCP server?
No, so in my environment right here, I have 4 VMs as Arista switches. Then I have a separate VM that's Ansible Tower, and I have a separate VM that's the ZTP server. And the ZTP server is running DHCP.
Can you pull up your host bars that you had in GitHub?
Yep.
I'm just curious, the dictionaries, are those well-known names for like BGP and ACLs? Is that, or is
So-
that user-defined namespace?
So this is just, now as an implementer of Ansible, you could choose whatever data model you want. If you look at this leaf.yaml, I'm including this role, arista.us virtual router, and in that, I've defined this, where'd it go? I've defined this data model. So in that role, it's gonna look for an object called BGP, and then it's gonna loop through listeners, loop through neighbors. It knows the data model that I've already created, so the data model in the host bars maps to my roles. And so you have that flexibility to do whatever you want. But it's not standardized.
Okay.
Okay, so all of my switches are up. Now if you log into any of them, you could do a show run, and you'll see I've got basically nothing. I have a user, I have a host name, none of my interfaces are configured except for management 1 with an IP. IP routing's disabled, and I have eAPI configured. So same thing across the board for all the switches. So now when I go to, I can kick off this playbook here, which is going to essentially stand up my entire data center. And so if you're familiar with Ansible, you'll see some green and some orange. Orange means change. So Ansible, the modules have reached out to the switch and they've said, okay, I want to configure all these VLANs. They don't exist right now. Okay, so add them. So that gets docked as a change. If you look at host name, it's in green. So that means that the host name that I want to assign to it, and that's defined in my playbook, is already the set host name, so don't do anything. So we ran spine.yaml, which included all of the tasks to do basic interface config, BGP config, and then as we're doing our tours, you'll see more tasks are getting run against the tours because not only are we doing BGP and interfaces, we're also doing mlag and var. Okay, so it's done. If you look, we have, again, a mix of OKs and changed, and some skips where it didn't apply. And then if we drop into one of our switches, we can do a show IP route, and I have distributed BGP routes, show interfaces. If I drop into my tours, they're a little more interesting because I have var and mlag configured. So I could do a show mlag, and the association, the mlag association between my two leaves is up. I can do a show IP virtual router, and I see the shared addresses for var as well as the local IPs. So with really just one click, and even though the running of this playbook in Tower could run on a cron job, or I could have triggered it via ZTP server or some other process, and it could have been a true zero-touch bring up of my entire data center, right? Now we would expect when it comes to item potency that if I run this playbook again, I should have all OKs. So I can sit here and run this playbook all day long, and after the initial config, nothing should ever change, right? And so if you were worried about, someone during the day changing things, adding users, removing users, changing VLANs, adding VLANs, you can run this nightly if you wanted during sort of like a change window, and you can always be ensured that your config always stays the same. Okay, so just about wrapping up. Okay, done. So, and then we see in the summary, all green, all okay, all the tasks. Okay, so that is the demo. Any questions?
How do you remove
What's that?
How do you remove something?
Okay, so say I wanted to, now I don't have network access, so this will be difficult. But what I would do is, say I have my, so this is my Git repo, right? And so this is my entire infrastructure in a Git repository. What I could do is, say my spine, I no longer wanted VLAN 2 on the switch. All I would do is just delete it, and then do a git commit, git push up to GitHub. Go back to my project, update my project here through SCM update, and then run my playbook again, and then you'll see the module will now remove the VLAN from the switch. And what's nice about this is I can have this playbook here, VLANs only, and so say this configure the entire data center is something you only want an admin to do, but adding VLANs, you don't really care who does that. So you can have some tiered approach to who gets to run which playbook, and then you could avail this to maybe just one of the, it doesn't even have to be a network engineer, right? And so he can go update the Git repo or whatever method you use, and then he can run that playbook and then just make small changes. Okay, so that is it. Thank you.
As I mentioned, we're going to raffle off these Arista Warrior books. So all I ask is put a business card into the fishbowl, pass it around right now. We'll pull 2 winners, and you guys will walk away with the Arista Warrior book. This really goes into the products. It's a lot of technical content. It's not just a marketing read.
Who carries business cards?
Details come from online interface and different commands you can use. With
Put a dollar bill in there, write your name on it.
Take another one.
Yeah.
I'll stick my barber.
Yeah.
I don't have the card.
Okay.
Don't have a business card. Can we write it on paper?
Yeah, you can.
We can?
Ready? Welcome. So I'm Mike Biancanello. I work for AOL, network architecture. And so I just wanted to say thanks to Fierce for providing all the refreshments for us. That was wonderful. Thank you. And so I want to start a conversation about network automation between traditional network engineers and the greater automation community. And so to kick this off, I'm going to talk a little bit today about what AOL is doing with respect to network automation, specifically about how we're using Ansible. So first, we are AOL. These are a few of my favorite brands. I'm sure some of these you know already. You love them. They're fantastic brands. Any others that you're not familiar with, I suggest go take a look at them. We're also hiring. So if there's anybody that wants to come work for AOL and support some of these fabulous brands, come see me afterwards and we can chat. But this is not why we're here. We're here because of the burden of adequate automation. And so it can be hard to justify spending all the time and resources to build something new when what you already have, it still kind of works. Like if there was nothing at all, this would be a really easy decision. You would just implement something. But the problem is that you already have something that's there. And so not only does this new thing have to do all the new stuff in the new way, but it also has to integrate seamlessly with all the old stuff. And so, for some of these things, you can draw a line in the sand, and you can say, we're not going to support that stupid thing that you do. And if you still want to do that stupid thing, you can still do it, but support is going to be manual, and it's going to be painful, and everybody's going to hate you for it. That's fine. You can do that for a few things. But for everything else, you need to build a bridge between the old stuff and the new stuff. So what we need to do is build an abstraction layer. And we need an abstraction between intent and implementation. And by implementation, I mean vendor-specific device configurations. And this abstraction layer will allow us to configure the network, as opposed to configuring devices. And so, for example, if you have to update the SMP string on all of your devices. So we have a script, I'm sure other people have a similar script that can push out commands to devices. And so you have to spend some time and figure out what are all the commands that you have to type in and execute on the switch to implement this change. And then you have to run this script manually at least one time for every variation in those configurations. And this is still automation. It still kind of works. And it's definitely better than logging into every one of those devices individually and pasting these commands in. Wouldn't it be a lot easier if you could just modify the value of the SMP string field in your data store and then click save? And that's what I mean by configuring the network. So it should go without saying, but it doesn't, so I'm going to have to mention it. This thing that we're going to build needs to be maintainable. It does us no good to spend all this time and build this thing if there's really only one guy that understands how to work it and operate it. So we looked at a number of different vendors and a number of different products for this. We even looked at rolling our own thing. And so, you know, Ansible is clientless. It's got tremendous vendor support. But for me, the biggest draw for Ansible was the code-to-feature ratio, where Ansible can deliver a ton of features without really requiring a whole lot of code, if any code at all. And so this becomes really important when you realize that this bridge that we have to build between the old crufty stuff and the new shiny stuff also needs to be able to support your engineers and your tech and your NOC administrators to be able to use and support these new tools. So we've identified a number of areas for network automation. There's the network lab, which is crucial. And I'm not talking about a lab where you can test your automation. I'm talking about automating the lab itself, so you can test engineering things. We have provisioning, which is pretty straightforward. It's a lot of ZTP and some device configuration. Maintenance is really where you're running. That's your engine. This is where you're configuring the network, and Ansible is just kind of running and making sure everything's implemented properly. And then you have reporting. And reporting is pretty self-explanatory, but I put this in here because you can use the output of your reporting to feed back into your maintenance and modify your data store, essentially. So the network lab. So like I said, you know, a network lab is critical to have and to be automated. And so when you have a lab that's very cumbersome and difficult, time-consuming to set up, people just don't test stuff. Why would you spend an hour setting up a lab for a test that's only going to take you 5 minutes to do? So we installed a layer 1 switch, which, for anybody that doesn't know, is essentially a programmable patch panel. We cabled a whole bunch of our stuff up into it. And then I have a playbook. And with this playbook, I can tell the layer 1 switch to go ahead and change physical topology, and then go ahead and blast out configs to all the devices that are part of that topology. And so now I can switch from a spine leaf to a jellyfish to a tier 1 backbone topology with a click of a button, just running one command. And the other thing this allows us to do is I can save a snapshot of my work. I go home, I go to lunch. Somebody else in the meantime can come in, do a different test with a totally different topology and a totally different set of configs. And when they're done, I can come back and just pick up where I left off. And we do all this with Ansible. This is our engine maintenance mode. It can, Ansible can either run on an interval, it can be triggered to run when a change is detected. This data store really stores the desired state of the network. Ansible runs, it checks data store, and makes sure that the state of the network matches the desired state. So you need to change an SNMP string, you modify the value in the data store, Ansible notices a change, and implements a change.
Are you running Tower? Or
No.
open source?
And likewise, when you have to install a new switch, you plug the new switch in, ZTP, you return just a baseline config that all it has to do is just so Ansible can reach it, and then modify the data store with the information about that switch. So when Ansible runs, it detects it, it configures it, and brings it up on the network. So provisioning is where we are currently building our bridge. And so our current methodology for when a device is provisioned, at provision time, a full device configuration is generated and stored. And then when the device comes online, that config is applied to the device, either via ZTP or copy and paste manually. And so what we do is we're going to replace that config generation with an Ansible Jinja model. And so what we've done is we have implemented the abstraction layer into something that has now integrated seamlessly with our existing toolset. And so the other thing we can do with this is, since we're generating full device configs, we can also generate full configs for live running devices, and then compare them to the actual config that's running, and then use that diff to be able to tweak our data model, make sure we have the right level of abstraction built in. And so the way we've organized our data is it's all surrounded around intent. You should be able to read a file, read a group vars file, and understand the intent of that. And so a playbook for us, kind of like Arista showed, is just a list of roles or features. And the combination of the playbook plus the group vars for that classification device is a description of the intent that we have for that device. And we should be able to take that definition of that device class and apply it across any routers, any vendors, any devices. And it should still hold up. So for example, when you read the playbook, it should be fairly obvious that, for a Tor switch, it gets OSPF, PBR, and QoS. When you look at the group vars file for the same Tor, it should be obvious that the uplinks get OSPF on them. And then to map physical interfaces to this intent, we create subgroups for each device class based on vendor and model. And so what this looks like, I'm not sure if you can see the, so you can see where I kind of highlighted this. Under interfaces, we label this uplinks. And these are all the characteristics for our uplink interfaces. And then that's applied to a Juniper switch, an Arista switch. It doesn't matter how it's applied. The only thing that really changes is the name of the interfaces. And all of these attributes are applied to all of these interfaces. Which brings me to Snowflakes. One of the things that I discovered as I went through this process was how many completely different variations of configuration that we have in our network, and it's saddening. So you want to avoid snowflakes. And hopefully by iterating through this process, we'll discover a lot of things that don't necessarily need to be different. And we can use this to iterate through and remove as many snowflakes, hopefully all of them, as possible. So questions for everybody else. How do you handle or disallow snowflakes? What have you chosen to automate? What wasn't worth the effort? And is there anything that you found that's too scary to trust with automation? That's all I have.
Decom the snowflakes.
Yeah. I mean, from the server, I can't speak for the network folks, but from a server's perspective, yeah, you usually look at what it's doing and try to refactor it into something that's more general purpose. We're using the same content, but making containing the uniqueness inside host vars, for example. That's your only differentiator is the inputs that are going into the Ansible roles that are making the changes to the machines. But you're still, at the base level, you're still using the same Ansible content. But maybe these snowflakes are so different that that's not the case.
Right, so there are always attributes that are going to be unique to each device, right? The host name, IP address, I mean, you can't get around that. They're going to be unique.
Sure.
I'm thinking of, this one top of rack switch we're running multicast on, but none of the others. We're doing this one thing on this one switch. We have a VPN connected into this one top of rack switch, but none of the others do that.
And that's on purpose, right?
Maybe it shouldn't be called a TOR switch.
So, from an organization perspective, something that when I talk to customers, they have trouble with is getting started. So what was the first thing that you tackled internally with Ansible? Was it like a lab or?
So what I did is I created a role called common, and I took my device config and I threw it in there. And then I created my playbook, and I had one role listed, and it was common. It was just base everything. And then I grabbed another switch and said, all right, now how about this one? And started going through like that and saying, all right, well, here are the things that I can pull out. And then there's some things that are really easy to identify as roles, like OSPF, BGP, even those things are obvious things. Things that don't go on every single device, right? So if it doesn't go on every single device in my entire network, like TACX. TACX is fine, but I would create a role for it, and I'd move those bits of the config. And then, remember, for this, all of our tasks are just generating templates right now. And so, but the idea is that we can use this to build our data model, and then we can use that data model to do anything, because now we've modeled the data. But so I guess that would be my recommendation for getting started. I mean, start with one big thing and then start peeling things away as you can. And then, take a number of use cases. Take a top of rack switch and then grab like a spine switch and say, okay, now I'm going to try to implement the spine switch. And you're going to realize, oh, I put some stuff in the common that really doesn't apply to the spine switch. That needs to be moved down. And so anything that's a differentiator, move it up, model it, create a role, and apply it.
In your evaluation of Ansible versus the other competing tools, was there any features that you saw in the other alternatives that you wish were in Ansible, or did it just basically do everything you wanted?
Feature sets from everything that I saw were pretty standard. And they all have options, like you can always add your own features to them.
Well, in order to run Puppet or Ceph, the target system is required to run Ruby or some sort of be able to install Ruby, or Ceph has its own like omnibus install. For network devices that you cannot do that, or like any appliance that you can SSH but you cannot run Ruby on it, you have to use something like Ansible.
Okay.
That was one of the bigger things, was the clientless. So, you know, of course, a lot of network vendors are starting to implement Chef and Puppet, and I know Arista's got a couple of those, Juniper as well. You know, but you know, we still have a lot of legacy stuff. And so, and plus, just the ability to have one thing that's clientless. We don't have to install anything on the device. Is really nice.
How many systems are you, how many network devices are you managing with Ansible?
We're not managing any right now.
Oh, okay.
We are, you know, we're rolling out right now the provisioning and integrating Ansible into the provisioning process.
Okay. Okay.
How many systems do you plan to support with Ansible?
All of them.
Like a number?
5?
5,000.
5,000.
So my next question would be, okay, if you have like 1,000, do you guys have any plan to scale Ansible? Because from one server, doing like 5,000 sessions is going to be kind of crazy. So do you guys have like thought about how you're going to like manage thousands of systems with like, you know, how's going to be the setup?
We have not gotten there.
Well, I mean, like Ansible forks, but it doesn't fork all at the same time, and then you can organize your playbooks in ways that they run sequentially and then parallelize where it makes sense. And then Ansible scales to hundreds of thousands of nodes anyway, so it's not like, I don't think network devices are Ansible's problem.
So we also have
sessions. You can have like, you know, for every device you need to have an SSH session. And yes, you can group it up, but like, you know, if you want to deploy something and you want to deploy in the next 30 minutes, you cannot do that like, you know, 5,000 servers from a single host, right?
So you can fork Ansible tasks in parallel. So that's what the fork option is about. And it's all dependent on the amount of memory that you have on your machine. So the higher number of forks, the more memory is consumed on your Ansible control node. I've forked up to 500 forks on a machine and executed a single task across 500 machines in, I don't know, 3 seconds.
Okay. All right.
So also, you know, we also have tools today that are running that, you know, like every morning they log into like every network device and run a bunch of commands and grab the output. So I guess I kind of see that almost as a solved problem, but I mean, logically we'd probably, if we had to, and split it up, you know, there's logical groupings that we can find it.
And typically in the larger deployments that I've seen, people don't want to target all of their infrastructure at once, because if you screw something up, you're going to screw up all your infrastructure.
Yeah, that's why I was thinking. Like,
Yeah.
So you don't want to have all your eggs in one basket. And,
Yeah.
like if you have multiple Ansible servers, how like.
Well,
Because,
no,
like, the
no, what I'm
deployment
saying
has-
is, if you're deploying a new software release, you're going to do it in phases, because you want to make sure that each phase is successful before you proceed to the next. Or some other canary-based deployment methodology.
Okay.
Yeah.
So one of the things is, you know, because Ansible is clientless and it can actually talk to all your legacy devices, so why don't you reverse engineer, you know, kind of rebuild your data store by playing a playbook from Ansible onto all of those, and then collect your data model back, and then look at it to say, you know, what is the, you know, course level aggregation that you can look and say, oh, this is common, that I can build a one level of you know, abstraction of that, and that would be a playbook that you can actually replay. So instead of, you know, thinking from, you know, playing this thing onto the switches, you do the reverse engineering of, okay, so I'm going to write an Ansible that's going to go and read off all these, and then I'm going to collect that data and then analyze it, and then raise that abstraction, because it's more like, you know, you're trying to, you know, work with the legacy data. So the only way you can do is either you have the knowledge of it. If you don't, you collect it. So to be honest, I think that's how it should look like. Like if I were to come in and say, okay, so what am I going to do? I don't know anything about this. So the first thing is you learn. And the way to learn is either you have that data that somebody can give. If you don't, then I'm going to reverse engineer what is there. And then build on top of that. I think that looks like
That's just not the that's not the Ansible model though. So that's probably why he's not doing it that way, right? I mean,
We actually do something like that. We just don't use Ansible to collect the data and.
Right. I mean, any Ansible, and even without knowing Ansible, you should be able to say, because Ansible, as much as it writes, it should also be able to modify, right? So you added 4 interfaces, you have to take one away. That should be possible by Ansible. And even without knowing, that is something that a tool should support. So once that capability is there, that means it can read. So if it can read, you can reverse engineer.
Yeah, so it does. The thing is, it doesn't, you can't run a module and then get back what the data model would look like, because when a task runs, it's taking the data model, applying that to your tasks and doing variable substitution and then running the task. So there's not an easy way to build that data model in reverse. You'd have to create another module that did that. But yeah, it does read, because that's item potency. That's how you figure out what's already on the switch,
Right.
and then you do a div and you figure out what needs to change.
I mean, you might have to, have a custom built module, some sort of, enhancing the Ansible to collect that and maybe come up with a common place where you can place that and then maybe read it back. So one of the ways, which is going to provide that data back to you, you should be able to get it back.
I think on the topic of snowflakes, making it difficult to create the snowflakes is a good way to combat it. I think what you were showing, where you could kind of push it on a regular basis, like if it checks and sees a difference, push the new config. So that way, if someone goes in there and mucks around with something they're not supposed to muck around, well, say it runs a nightly job, it's going to get replaced. And then, forbid if they were not supposed to be doing it in the first place, they're going to have to answer for that, figure out why it happened, stuff like that. If they were supposed to be doing it, there should be a process to make that difficult to be able to get in there and do that.
Yeah, I think that's kind of the Ansible methodology anyway, where your data store is your desired state of the network.
Yep.
And if somebody goes in and they change the configuration directly, then when Ansible runs, it's going to reverse that.
Where do you keep your authentication credentials?
That's a fantastic question.
I was going to ask that. That's a good one.
So Ansible Vault is kind of cool, but it requires you to type in your password every time you run Ansible. I've looked at a number of places, and there just isn't a really good place to store. I mean, you don't really want to store your encryption keys and Git.
Vault supports reading from if you want to store your password in a plain file, you could read it from a file.
Right. So, where does that file live?
Somewhere
And
safe.
how do you make sure it has that file?
Very close to your heart.
Right. So I mean, you could put everything in Vault, everything get a password from a file, and have that file just be distributed on demand. Right? Somebody has to come and say, hey, can I have the file so I can install it on my system?
So each time you run Ansible, you have to provide a password if it's in Ansible.
Yeah, and then if you do the file, maybe somebody can point me in the right direction here, but I believe it's not just Ansible playbook and then the playbook name. It's Ansible playbook and the playbook name / grab password from file equals and then the path to the file name. And it's kind of a so for the lab. In order to get that set up, I actually wrote a Python script that runs Ansible. So now now my Python script I can have it be something that's easy to type in and understand, as opposed to running Ansible with extra vars and all the options. I can have Python do that for me. Makes it easier for the user. Any other questions?
Hey Mike, but across those 5,000 devices you mentioned, how many different profiles would you have typically?
How many profiles should we have? There really shouldn't be any more than 5 to 10 maybe. If I were doing this from scratch, right? Maybe 5 at the top, at the most 10. In reality, because we already have a bunch of snowflakes out there, probably a bit more. Either that or a very complicated mechanism for creating subgroups.
Are you including the load balancers, firewalls, and all of the...
I did not include all those in that,
Yeah.
but yes, that would be even more. Is anybody else using Ansible for networking stuff that's here today?
We're just using it for big templating right now and working on orchestration, testing the waters right now with that. Similar sort of thing where generate a configuration for a role and hope it or do a ZTP process to get a provision from there. But we're really curious about some of the modules that being added with 2.0, being able to work with vendor modules.
How much like pushback did you get from management or your coworkers about this, doing this?
None yet.
They just found out today.
Like I said, I don't have, Ansible currently is not running and managing the live production devices.
Yeah.
Right now it's running for the lab, and we are about ready to pull the trigger on having it generating configs for new device provisioning.
Cool.
And like I said, in the new device provisioning, it really helps us build that data model. So.
One of the things that helped us was abstracting our architecture and our different components and creating roles. That's what we spent a lot of our time, is saying, okay, we have this architecture, we have these functions within our network, let's define roles, Ansible role, and that's how we're disallowing snowflakes. But there's the legacy piece where it's like you said, you have one device running multicast. That to me is, well, we have to create a snowflake role for multicast of that function.
Or snowflake group.
Yeah.
It's better to have your snowflake captured somewhere in a Git repo than just, you don't know until you log into the box and figure out that it's a snowflake, right? It's this documented snowflake at that point.
Yeah, a lot of the snowflake configs really should come from either inventory or gather facts.
Outside your group, is anyone else AOL running Ansible?
There are a few of the ad tech or advertising groups are running Ansible, and there are a couple pockets here and there for servers.
How about to flip the question around on you? Is there something that you didn't trust with automation to begin with, or still don't?
Switch upgrades?
Well, everything originally, it's been a long process to get people, network engineers to think differently about originally things apart from typing in the command themselves. So it's been a long, slow process to get.
Yeah, that's a fair point. It's framed in here. The answer, he said everything at first. It's not trusting until it earns a level of trust from you. Like like switch upgrades is probably going to be the last thing that we tackle. And because you want to be careful, you don't want outage at scale, right? You don't want to fork your switch upgrades and reboot 500 of them at the same time. All right. Well, thank you.